Today we're going to calculate mean absolute deviation, or sometimes you'll just see it on a worksheet as just MAD. And the mean absolute deviation is how far, on average, are all the values in a data set from the middle or from the mean. Before we figure out how to actually do it, let's take a look at why we would need to calculate the mean absolute deviation. So let's take a look at some test scores here. So we have three classes here that have taken a test. And you can see overall everybody did very well. The mean and the median in this test is in the 80s. The mean and the median in this test is very good. And the mean and the median in this test is very good. So overall, all these classes did a really good job. And the mean and the median and the mode are called measures of center. Or sometimes you'll hear them called measures of central tendency, or just averages. And these tell us, on average, how did everybody do on this test? And like I said, they did pretty well. But then we also have these other measures when we're looking at the data. The range and the mean absolute deviation. They're a little bit different. They're not measures of center. They're measures of variability. And a measure of variability is just like it sounds. How much did the data vary? Let's take a look at this first set of test scores. And just a quick look at test scores in Class A, you can see everybody did really well. There's 70s, there's 80s, there's 90s. And the range, or the distance from the very highest score, that 100, to the very lowest score, that 78, there's a range of 22. The test scores were all pretty close together. And the mean absolute deviation is 5.5, which is pretty small. And again, we're going to figure out how to calculate that in just a minute. So you can see there was very little variability in this data. Now in this next set of test scores, there is a much bigger range. We have a range of 48 because the highest test score was 100. It goes all the way down to the lowest test score of 52. And you can see there's a lot of variability in the test scores. We have students in the 50s, 60s, the 70s, the 80s, the 90s. There's a lot of variability. So there's a high range, and there's also a much higher mean absolute deviation in the test scores. There's more variability in our data. Test scores in Class C are kind of interesting because there's a huge range. There's a range of 82. So it might look at first glance that the test scores were just crazy all over the place. But we can look at this and most of the scores were in the 80s and 90s, but we have this 18. We have that lowest number, and we've got a 22 over here. We have a couple outliers, and those outliers make it look like the range is much bigger than it really is. I mean, the range is 82, but it makes it look like the data is varying a lot more than it does. So we need another measure of variability to get a much better picture, a truer picture of what's going on. And so you'll see here that our mean absolute deviation is 5.5. There's really not a lot of variable in the data except for those outliers. Okay, so let's talk about how we're actually going to calculate this. So I have a new data set to work with here. So let's get started. So I've put the data on this chart, the data points from right here, and I've put them on the chart, and I've calculated the mean. The mean of this data is 22. Now the first step in calculating the mean absolute deviation is to figure out what is the difference between each data point and the mean. So, to use our test score analogy, and it's important to point out that mean, median, and mode, and mean absolute deviation, I'm using test scores as an example, but that's not the only real-life scenario that you would use these for. There's a lot of different reasons why you would use mean, median, and mode, and mean absolute deviation. So, but let's keep going with our test score analogy. So if the average score on this test was 22, this person got an 11, that's a difference, that's 11 points smaller than the average. 9 would be 13 points smaller than the average. 36, that would be 14 points more than 22. 28 would be 6 points more than 22. 7 would be 15 points less than 22. And 41 would be 19 points difference. So we figured out the difference, mean absolute deviation. So we have our mean right here, check. The deviation is how much does something vary or how much is something different. And now we get to why it's called mean absolute deviation. Now the data point 11 is 11 smaller or 11 less than the mean, which means it basically means it's 11 points away from the mean. And really it doesn't matter if that data point is 11 points towards smaller or 11 points bigger than the mean. It's just 11 points away from the mean. The data point 9 is 13 points smaller than the mean, which means it's 13 points away from the mean. So that's where we get that absolute. When it's talking about mean absolute deviation, we don't really care if these data points are bigger than the mean or smaller than the mean. We're just trying to figure out how far away from the mean they are. And now it's time to complete our calculation. We have figured out the absolute, we've done the calculations to figure out the difference between the mean, each data point and the mean. And now it's time to find the mean of these data points. So we're going to add these all together. We get 78. And we just added 1, 2, 3, 4, 5, 6 data points. So we're going to calculate 78 divided by 6. And 78, I'm going to write that down to 78 divided by 6 is 13. So our mean absolute deviation is 13. So to review, to find the mean absolute deviation, we started by figuring out the mean of the data points. Then we figured out how far each data point was away from the mean. So for example, this data point 41 minus 22 is 19, so that data point is 19 points away from the mean. 7 minus 22 is negative 15, so that is 15 points away from the mean. Once you have all of your calculations here, you're then going to find the mean, because we are finding the mean absolute deviation. So these are our deviations, and on average, how far apart are each one of these data points away from the mean? To find the average, we add all the numbers up, and then divide by the number of values. And there are 6, we use 6 data points, so I took that 78 and I divided by 6. So our mean absolute deviation is 13.